Number 5 looks a little tricky because of the fraction. We see we have e to a function other than x. So we have e to an inner function. So our u is actually going to be the square root of x, which we know is x to the 1/2 power. Whoops, let's get that on the screen. Sorry about that. So when we go to du, the derivative of x to the 1/2 will be 1/2 x to the negative 1/2, which gets kind of tricky because that's not located anything in here, it seems like. However, if we were to rewrite this, we have a fraction with the 1 in the numerator and the 2 in the denominator. The x will become x to the positive 1/2 if we move it to the denominator. And we know that x to the 1/2 is the same thing as the square root of x. So du will be 1 over 2 times the square root of x dx. Well, we already have the square root of x in the denominator. We're just missing the 2. So if we're to have 1/2 that we've brought into our function, that means we need a 2 on the outside. So what does this tell us? Twice the antiderivative, we have e, and then square root of x is u, so we have e to the u. The 2 and the square root of x that are in the denominator, they're going to leave the problem along with the dx when du comes into play. So we have e to the u du. So really this is a nice simple antiderivative. We just had to work to get that 2 out front. And finally we need to place our square root of x back in. So this is 2e to the square root of x plus c. And that we can see is answer A. And keep in mind with this problem and with all the previous problems, if we want to double check our work, we can always look at deriving our answer. And that will give us an opportunity to see if we did our antiderivative correctly. With number 6, we have e to the x and 1 plus e to the x. This looks rather tricky. If this was reciprocated, if this was 1 plus e to the x over e to the x, then we could break it up into 2 fractions. But we have the binomial, well, rather the 2-term expression in the denominator, and that is not able to be split up rather easily. So we're going to have to make u equal to that denominator. But that's okay because the derivative of u, well, 1 derives to 0 and e to the x derives to itself. So the derivative of u will be e to the x dx. And lo and behold, that's exactly what we have. So our antiderivative turns into, well, we have a fraction bar, which was not part of u and du at all, so we need a fraction bar. And then we have e to the x dx, which is replaced by du, and 1 plus e to the x, which is replaced by u. This is our classic natural log antiderivative. You could also think of this as 1 over u du, if that prefers, and that looks just like our 1 over x dx, which again leads us to the natural log as we do our antiderivative. So we have natural log, absolute value of u plus c, and that means we have the natural log of the absolute value of 1 plus e to the x plus c. So going to our answers, we see that we have a couple with natural logs and a couple without, and we don't have any absolute value at all, and that's just one of those things where we only need the absolute value if there's a chance that our expression is going to be negative. When we know that e to the x is always positive, and when we add 1 to something that's always positive, it's always going to be positive. Which means we don't need the absolute value markers for this solution, although there's nothing wrong with having them there. Alright, and finally number 7, which of the following is the solution to the differential equation dy dx equals 2 sine x with the initial condition y of pi equals 1. So we see this new term differential equation, and that's going to be coming up a bit more. We're actually dealing with differential equations right now. No big deal. We see the derivative, we see dy dx, and we see all of our answers are y equals. So our idea here is that we want to antiderive 2 sine x. Alright, in doing so, we are looking at, okay, well, 2 is a coefficient, so that's going to be a part of our regular function, and then sine x. Alright, well, sine antiderives to negative cosine x, so we're going to have negative 2 cosine x plus c. This is our y function. Alright, but we need to figure out what c is equal to. We know that when we plug in pi, we get 1, so 1 equals negative 2 times the cosine of pi plus c. And the cosine of pi is negative 1, So we have 1 equals negative 2 times negative 1 plus c. So 1 equals 2 plus c, and c is equal to negative 1. That negative 1 is going to move right up there, so we see negative 2 cosine x minus 1, and our answer is E.